All right, so 1.4 is we're getting into more of the basics of these polynomials and things that we're going to be using. So let's first talk about all of the pieces of a polynomial. Okay, so let's talk about this top box on this diagram. So this is pointing at this number, the little number that's above the x, which is called the exponent. So the largest exponent, and I want you to write this down. So the largest exponent is called the degree of the polynomial. So this is, the largest exponent on this one is 3. So this is a third degree polynomial. Okay? So the number, let's talk about this on the left. This one is talking about this number right here. And that is the number out front is the leading coefficient. All right, now for the bottom blank, this is pointing at every single one of these terms is what it's called. So it's like how many pieces in a polynomial, and these are separated by plus or minus signs. Okay, and then the last thing is the number without a variable, and that's just a regular number, and they call that the constant. Okay, so if I say constant, it's the number without a variable. Okay, like terms, this is huge. So like terms have the same variable to the same power, or constants. Okay, so constants are always like terms. You can always add, they're just regular numbers. You can add them or subtract them. The other ones have to have the same variable to the same power, so the same exponent. So let's draw connecting lines to the like terms. So we've got 4x goes to 7x, right? Because they're both x's. All right. 17, that is a constant because there is no variable. And that looks like that matches with 11. 6x squared. I'm not seeing any x squareds. And you cannot do this. You can't do 6x squared and 7x because they are not like terms because they have different exponents. It does matter. Okay, 19y to the 5th. Y to the 5th looks like it's over there. So those are like terms. 75z. 75z and 16z squared, that's the only one, but I can't do 16z squared because it's z squared and not just a regular z. So that's out. I guess it doesn't have a like term. And then y, looks like I have one with y, the 4y, not 2y squared, because again, they're not like terms. Okay, so now let's start simplifying these. And so how you do this is you combine all like terms. So you can only combine like terms, you can't combine unlike terms. So when I like to do this, I like to underline and I put little squiggles on what the sets of like terms are so that way I don't miss any. So 2x and 8x are like terms. And then -4 and +3 are your constants, so we can combine those. So I do like that. I do the underlines and the squiggles. Sometimes I do other stuff, but depending if there are more. Okay, let's do the x's first. So 2x plus 8x gives you 10x, right? Because 2 plus 8, you just add the coefficients, the numbers in front of the variables. And then -4 plus 3, you have to combine like terms. So -4 plus 3 would give you -1. And this is your answer. I know it looks weird. It's not just a number answer like you're used to. That's okay. Don't freak out. It'll be all right. Let's do another one. So let's identify the like terms. Looks like I have y, 4y and +y. and negative 3x and negative 6x. Okay, so 4y plus y. So if this y messes you up, you can put it as 1y. So 4y plus 1y gives you 5y. And then be careful with these negatives. Negative 3x minus 6x would give you negative 9x. And can you combine them any further? The answer is no, because they are not like terms. So that's your answer. Okay, here's another one. So it looks like I got some more. So I've got x's, I'll underline those. And y's, I'll put squiggles on those. So let's do the x's. 3x and a positive 9x. That would give you 12x. Positive 5y plus 7y minus 4y. You can do that all at once if you would like. You could type in your calculator 5 plus 7 minus 4, and you would get 8. And don't forget that we're talking about y's, so there needs to be a y on it. All right. Ooh, now we're getting crazy. I gave you some exponents. So I've got negative 7p squared and negative 8p squared. 4r. And is 4r and 2r squared like terms? The answer is no, because you have an r and an r squared. So that one is something different. So they're not like terms. So you cannot combine them. So it looks like the only thing I can combine is the p squareds. So let's go ahead and do that. Negative 7p squared minus 8p squared. Be careful with the negatives. That gives you negative 15p squared. And then since I can't combine those other two, you can just drop them straight down. So we have a plus 4r plus 2r squared. And that will be your answer. All right, the last thing for these notes is the distributive property. It's so fun. So the distributive property is when you have a number or something outside of a set of parentheses, you have to distribute it in. And when you're doing that, you're multiplying it. So when you distribute the a in, that's the same as a times b. And then a to the c, that would be, and then you add it since there's a plus sign in the middle, plus a times c. So that's the property. That's how it works. So remember, you're multiplying. Multiply, multiply. Okay, let's do one. So 3 times x gives you 3x. 3 times positive 2 would be positive 6. So if you leave your answer like this, 3x, 6, that doesn't make sense. Since that 6 is positive, you must put a plus sign in the middle. Now let's double check. Can we combine like terms? No, we can't. So there is your answer. Okay, let's do this one. 4 times 2x would give you 8x. 4 times negative 6 would be negative 24. Perfect. Okay, so negative, let's do another one. So now this one has a little bit extra stuff. So this negative 3 is only being distributed into the stuff in the parentheses. Do not distribute it over to the 8 because it's not inside the parentheses. Okay, so negative 3 times 7x would give you negative 21x. Negative 3 times negative 1 will be positive 3. And then I'm just going to drop down that plus 8 because there's nothing to do with it at the moment. Okay, so now, since we have everything down, now we have to check for like terms. Looks like I have 3 and 8 are like terms. So let's go ahead and combine those. So positive 3 plus 8 would give you positive 11. And then drop this down, the negative 21x, because there were no like terms to combine it with. And that will be your answer. All right, last one. Ooh, this one's getting crazy. You have 2 things to distribute. That's fine. So let's do the first one. 5 times x would give you 5x. And 5 times negative 4 will give you negative 20. All right, now on the other set of parentheses, it looks like we're distributing in a -2. So -2 times x is -2x, and -2 times 2 is -4. All right, let's look at combining like terms. Looks like I have x's and constants to combine. So let's do the x's first. 5x and -2x make 3x. And then -20 minus 4 gives you -24. All right, that is it for this lesson. Thanks for watching. Have a good rest of your day.